Hey 8th graders, welcome to your lab for today. So again, this is mainly for DLI kiddos who are doing this at home. However, if you guys missed either the Monday, Tuesday for those last week A cohort kids or Thursday, Friday for those last chance B cohort kids, this is a lab you guys want to be doing to make up for it, or this is a video rather you want to be watching. So in today's lab, we're really going to look at energy transfers and looking at how energy transfers differently between equal masses of hot and cold water, unequal masses of hot and cold water, whether we have more hot or more cold, and equal masses of hot and cold substances, but not necessarily the same substances like water. Okay, so I can predict and test thermal energy transfers between equal masses of hot and cold water, unequal masses of hot and cold, and equal masses of cold water and hot metal. All right, so moving on, you guys first needed to start this lab off by making a couple predictions. Aside from question 1, these predictions all refer to a certain part of the lab that we're going to be going over. So question 1 states, what happens when something hot comes into contact with something cold? So if you guys put like ice cubes in a drink. So really think about what we've learned so far, our demos that we did on the first day, and what we just kind of learned about what temperature is and how it transfers and what that looks like. All right, question 2 refers to part 2 of the lab. What do you think the final temperature would be if you mixed equal masses of 0 degrees Celsius water and 50 degrees Celsius water? In the lab, you guys are going to be doing this something similar, but you won't exactly have 0 and 50. Okay, so what do you guys think that final temperature would be if you guys were to mix those two amounts of water that are equal to each other, that are 0 and 50 degrees? Question 3 again refers to part 3 of the lab. How do you think your results would have been different if you had used more hot water than cold instead of equal masses? So that's what you guys will be testing out on part 3. So again, if you guys have, again, 0 degrees Celsius water and 50 degrees Celsius water, but you have more of that 50 degrees Celsius water, what do you think is going to happen there? Okay, question 4 refers to part 3 of the lab. Again, same as question 3. However, you guys are looking at more cold water this time, so more of the 0 degrees Celsius water, less of the 50 degrees Celsius water. And finally, question 5, what do you think the final temperature would be if you mixed equal masses of cold water and hot metal? So same amount, if you will, but different substances. Okay? All right, so let's take a look at part 1, mixing equal volumes of hot and cold water. You guys can kind of just breeze over the materials, but you guys will see everything you need in the videos that I made for you to collect data. You guys will see how to do this. I explained the directions for you guys in the lab, so I'm going to skip over those. Main thing I want to go to is table 1 for the part 1 data. You guys have your video over here, so you'll need to pause this video, right-click this video here, and open it up to see part 1 and collect data for that little section. So it looks something like this. It's going to, of course, take. All right, and now I'm just going to kind of show you guys what that first video looks like. I'm not going to do that again. So here's your data table. First one you guys are going to see that I actually give you guys a temperature for is your hot water. So you guys will collect that piece of data first, then you'll do your cold water temperature, and then I'm going to mix those two, and you guys will find your final mixed water temperature. So record those 3 temperatures in this table. And then did the result of your experiment agree with your prediction? So if you guys look back, you guys had 0 degrees and 50 degrees, and you guys may have made a guess about how that temperature is going to look. Obviously, you guys won't have 0 degrees and 50 degrees for these, okay? But based on how you made your prediction, does that kind of fit how you guys saw your results turn out here with this? So maybe you guys said halfway, all right, this is 0, this is 50, so halfway point would be 25. I think my water would be 25, okay? Did you notice that between your cold water and your hot water, was it about halfway? Okay. Discuss and explain why the temperature value may not have matched exactly your predicted value. Moving on to part 2. Part 2 and 3, again, you guys are dealing with unequal masses of water. So you guys on part 2 are going to have more hot water than you have cold water. So that's the only part of the directions I'm going to point out to you guys. Before we had used 100 milliliters of hot and 100 milliliters of cold. For this one, you guys are going to use 120 milliliters of hot and only 80 milliliters of cold. So again, a total of 200, the same as in part 1. However, you're using a higher ratio of hot water. Okay, so back past all the directions, and let's go ahead to our part 2 data. Here's your video over here. Right click to open the link and watch. Again, you guys will record your hot water first. So I think the temperature I give you guys first. and then your cold water, and then you guys, after it has stabilized and we've mixed the two, what's your final temperature there? And again, based on your guys' prediction or what you guys predicted on those first pre-lab questions, how does that compare with what you guys actually discovered? Okay, part 3, again, similar to part 2, except you guys have more cold water this time. So we're going to be doing 120 milliliters of cold water and only 80 degrees of hot water for that one. Okay, so again, your data, I believe I give you guys your hot water first, then you get your cold water, and then you get your mixed water, and then answer the same questions that you've been answering. Finally, part 4. Part 4 is a little bit of complication here. What we did in all the other ones is I was saying, you know, here's equal masses, but really, in all honesty, we were using volumes. Because we used water for both our hot and our cold, it was easy to assume that mass and the volume were the same. So if I used equal volumes of water, I was also using equal masses. But because on this we are using different substances, we can't just say volume or mass, okay? So we're gonna stick with mass for this, and you guys will see kind of, I'll explain to you how I do it in there, but you guys will be using metal washers, finding the mass of that, and then you guys will actually be massing out your water instead of using a volume. Okay, so you guys can go through that. You, again, will see how I set it up, and I explain why I set everything up that way. Your guys' data table looks a little different. Very first thing I do for you guys is I weigh those washers, so that's going to go right there. And then I'm going to put those washers in hot water and get you guys a temp here. So that should be a hot temp for the metal. Then I go ahead and weigh out my cold water mass. If I did this right, my mass for my metal washers should be the same as the mass for my cold water, and then I take the temperature of the cold water for you guys. Finally, I add the washers to the cold water, and then you guys will give me your mixture temp there. And then why didn't the temperature of water and metal mixture come out halfway between the temperature of hot and cold? So you guys might have seen in your first one, it comes out roughly about halfway. So why was this different? Again, think about what we did when we did those thermal energy demos at the beginning of this unit. Explain what is happening between the metal washers and water in terms of temperature and thermal energy. Make sure for both of these answers that you guys use energy transfer somewhere in your answer, and not just saying Miss Crawford wanted me to use energy transfer in my answer, so here it is. All right, that concludes your guys' lab. This was a 2-day lab, so you guys can kind of spread it out, do 2 parts per day, hopefully. Or at this point, you're probably hearing that and saying, a little too late to tell me that, Miss Crawford. So either way, if you guys did it all today, you guys are done for tomorrow as well, okay? Make sure you hand it in, and I will talk to you soon. Have a good day.